So today we're talking about polygons. Okay, yesterday we had triangles. Today, so a special type of polygon is a triangle, 3 sides. But today we're going to talk about all the other polygons. And then as the year progresses, we'll even break it down into quadrilaterals and special types of polygons. So, all right, go ahead and define those there. Using a picture is definitely very helpful in that case. Okay, what is a polygon? Cameron? Good. A closed plane figure with at least 3 sides. So the one we studied yesterday, the triangle, is a polygon. Special one, it has 3 sides. We call it a triangle. Tri meaning 3. So any closed figure that would lie on a plane is a polygon. And you have different types of polygons. You have a concave polygon. Now, I like to think about these as we're kind of checking them out. That a concave meaning it would have a cave in it if you had a picture of it. So let me draw one real quick. The way I like to draw polygons, thank you, Logan. I like to just put some points down and then play connect the dots. Connect the dots, I truly believe is like, is a mathematical conspiracy against little kids. Just saying, so that we could get you to draw shapes without you really knowing. Oh, I missed that dot, so we're going to extend that dot over. I wasn't paying attention to it. I was too into the mathematical conspiracy piece. Okay, so there's our polygon. Now this polygon has 1, 2, 3, 4, 5, 6, 7 sides. It's actually called a heptagon. Okay, 7-sided hepta. We'll talk about that. But this is a concave polygon. The way I like to think about it is I was like on, Survivor, one of those shows where you have to go find your own shelter. This is like a little cave I can go in and I could do my little camp out here and, build my fire. It's a little slopey, so hopefully I can, hook it up or twist the cave a bit so that it's now a level, Yeah, twist the cave, There we go, then I'm good. All right, so the point is it has an overhang. The book definition says if you can draw a diagonal connects 2 vertices. However, it's not a side, so like this is a diagonal. If you can draw a diagonal that is outside of the shape, then it's concave. That's kind of the test they give you. Well, since I can draw this diagonal here from angle to angle, connects 2 angles. I think I said sides a minute ago. It connects 2 angles, okay, and it's not a side, then that's a diagonal. This one's outside of the shape, so therefore it is a concave figure. Versus a convex, if I had 7 points again, it's 3, 4, 5, 6, and 7. Okay, so did I put 7 there? 2, 4, 6. Okay, good. Okay, and then we play connect the dots, and I'll try to actually connect the dots pretty decent this time. That's 4 again. Okay. I obviously didn't play the game as much as a kid, but there we go. Okay, this point really should be, it's almost more of a straight line the way I've got it. So, but there we have our 7-sided figure here. Okay, connecting our dots. All right. Notice at any point, if I connect, say, that dot or that vertice to that vertice, the actual dots are called vertices, or any 2 vertices, notice all those diagonals, that's what we're drawing there, all those diagonals lie within the figure. That's a convex. Okay? I just remember cave because it makes a little cave. That helps me to remember that. It's just a memory device. So concave, convex. Any questions there? How many like my little cave story? Makes me feel good. Okay. All right, good, thank you. All right. Regular polygon. Regular means what? Diamond, what do you think? What's a regular? Yeah. Good. Equilateral and angular, which means what?
Equal sides and equal angles.
Good. All sides equal and all angles equal. Okay. Equilateral, equiangular. Someone tell your neighbor, or go ahead and tell your neighbor a name of a shape that is a regular figure. Okay, I heard square. That's a good one. That's like it seems to be the most popular regular figure. All the other regular figures want to be like the square. Okay? Yeah, all angles and all sides the same. It's a square. Equilateral triangle. Yes, sir. A circle is not regular. No. It's not a polygon, right? Yeah. No, circle doesn't work. Yeah. A star. A star does not have equal angles. Yeah. If you're thinking of like this type of star, right? As you do that thing, yeah, it doesn't. Right, but okay, but like this angle right here isn't the same as that angle. Okay, so if we were to finish up the star, Jackson. An octagon. It could be a regular octagon, right? Meaning all angles and all sides the same. Yeah. Regular hexagon. Yeah. A regular pentagon, right? So like this pentagon, which a lot of people look at and go, hey, that's my house. Okay, well, that pentagon is not regular. However, you can make a pentagon regular, like the actual Pentagon in Washington. Okay? What? Yep, it means it's because of the angles, yeah. Okay, so regular, all sides, all angles congruent. Equilateral polygon and equiangular. Well, equilateral means all sides are congruent. Equiangular means all angles congruent. Can you think of an equiangular polygon that is not equilateral? Think of a polygon that has equal angles, but it's not equilateral. It doesn't have all equal sides. You gave it away, dude. Okay, yeah, a good example of that would be a rectangle, right? Rectangle has 4 right angles. It's the one you have the most experience with. Okay, rectangle, 4 right angles, but all sides are not congruent. All right, very good. Any questions there? You asking a question? Oh, I thought you were asking Hannah a question. Yeah, they call them mathematical symbols. We call that math. All right, I want you to take a look at, let's study the names and the number of sides in theorems, or for the polygons, and theorems 2.3 and 2.4. In fact, let me just put up the names real quick. And if you want, you can put these in your notes. Some of them you already know, some of them you don't. Triangle has 3 sides. Hopefully you know that one. Quad. Quad meaning 4. Okay, 4 sides. Quadrilateral. Penta. Penta is 5. Hexa is 6. Hexagon. Hepta is 7. Hi. Yeah, sometimes they call them septagons. Yeah. 2 different root words. Yeah. Octa, 8. Nonagon is a 9. Deca, meaning 10. Bethany, how you doing?
I'm fine.
Yeah. You know when you talk and I talk, it's distracting to me and it makes me lose my train of thought. Yeah. Dodeca, meaning 12. Yeah? 11's not in there, but I'm sure it has some cool name. We just don't use it as frequently. Yeah, well, let's call it an 11agon right now. Okay, so inagon is anything beyond 12 that we don't have a name, or we don't have there's a name for it. Someone has a name for it somewhere. You could probably Google it and figure it out. Okay, you can look it up in some math text. However, the n will replace whatever. So if it's a 15agon, or 15 sides, we'll just say 15agon for now. Okay, that's how many sides. All right, but these are the most commonly used ones. Okay, these are the ones I'd expect you to know by name. All right? So on your test, if I reference these, you can't come up to me and go, hey, McCoy, what's an octagon? I can't tell you that. You're supposed to know that. So if you don't know these, how many know at least half of them? How many know all of them? Wow. All right. Well, good. I'll have to quiz you at some point. Walk down the hall and say, decagon, and you'll go,
10.
you guys just failed the quiz.
Oh.
Dodecagon.
12.
Oh. See? Nonagon.
9.
Uh-huh. Septagon plus octagon.
And 15.
Ooh, 15. Just saying. Okay. Hey, theorems 2, 3, and 2, 4. Go ahead and look them up in your book there. I'll set this over here so for those of you checking it out.
Oh, it's called the Polygon interior.
Angle sum. Angle sum.
Yeah.
Oh,
Like-
gosh, I can't write.
We don't have homework in here. We have daily work.
Wait, so does that mean that we did this for nothing?
Huh?
I'm gonna
Well, no, you have to finish it.
But
You have to finish your daily work. Okay. Here we go. Yes, you will.
thank goodness. Okay, 'cause I was hard
Okay, let's talk about theorem 2-3, the polygon interior angle theorem, because, you know, it has to have its own name. Okay, polygon interior angle theorem. The sum of the measures of the interior angles of an n-gon, is n minus 2 times 180. How many agree with that? Well, yeah, the book says it. I mean, you have to agree, right? The question is why? Right? What if we studied that has 180 degrees? Triangle. So let's say I have, let me just make a shape. Let's make it an octagon because it sounds cool. Octa. Okay, 2, 3, 4, 5. You'll notice every time I draw my shapes, I keep putting dots and I connect them. And sometimes I'm better than others. Okay, there we go. The octagon. There's my octagon. 8 sides. Now, if I can take and draw diagonals, in fact, why don't everyone draw your octagon? Draw your own octagon. Now, you'll notice I have dots where my vertices are. You usually don't see big points where the vertices are, okay? But, you know, when we're getting used to drawing these shapes and you're drawing them freehand, the dots are helpful. And if you really wanted to be doing well, you'd use a straight edge and you connect dots and then erase the dots and make them angles, okay? I'm not getting that picky about it right now, but when I draw this, what I'm going to do is I'm going to pick one vertice. In fact, I'm just going to pick that one, just because there was no reason other than that one looked kind of lonely, okay? So I picked it. So I picked that one, and I'm going to draw diagonals to every other vertice. Now note, from here, from this vertice, if I call that vertice A to vertice B, is that a diagonal? No, a diagonal connects two vertices and is not a side. A line that connects two vertices but is not a side. So A to C is a diagonal. Now I'm going to stop right there. What have I formed by drawing that diagonal? A triangle. In fact, I have this angle, and I'm going to be very careful in my coloring. I have that angle, and that angle, and that angle. And all those angles add up to what? 180. So I'm going to do like a 180 counter here. So how many times I get 180? I've got one 180 so far. Okay, now I'm going to draw another triangle from that same vertice, from here to there. Okay, notice I have that piece, and now that piece, and that piece. How many degrees is that? From here to here to here in this triangle? 180. Every triangle has 180, so now I have two 180s. And now if I go from here to, say, there, notice what did I form?
Another triangle.
Another triangle. And that triangle, have I highlighted any of those angles? No. But how many degrees is each of those total when I add them up? 180. When I add them all up, all three of those, I get 180 again because it's a triangle. And then I'm going to highlight them just to show that I've actually highlighted. Now you'll note something here. In my first highlighted mark for angle B, I've got that whole angle. Angle C took my first and my second together, but I've got the whole angle. If I called this angle D, notice I've taken that whole interior angle now. Have I got the whole interior angle for angle E yet? No, but notice when I draw in this triangle, how many degrees? 180. There's another 180. And I get the rest of D right there. Plus that piece and that piece. Notice I still haven't finished off angle A yet. Okay, but I do have part of angle F. If I draw in my other diagonal, notice I get another 180. And I get that piece right there, as well as that piece. So I just finished off angle F, and that piece, which is first part of angle G. And my last triangle's already drawn for me. Hi.
Wouldn't there also be more angles like AF and C?
Well, give me 1 minute. Let's finish off this thought. Okay, and then we'll ask the questions. Have I taken into account all interior angles now? Yeah, I have, right? So let's finish this and we'll come back to your question. How many 180s did I have?
6.
6. How many sides did I have?
8.
8. N stands for the number of sides. So N times, what was our formula? N minus 2. So I have my 180 there. Okay, well, it's not 8 times 180 because how many 180s did I have? 6. So this piece right here actually has to change to N minus 2 times 180. Okay, N minus 2 times 180. That is our formula there. Okay, it's the number of sides of the figure, not times 180. You got to subtract 2 from it. Okay, and that'll happen every time. If I drew, let's just pick a quadrilateral for the sake of ease. What is N here? Yeah, here N is 4, right? So if I'm using my formula, it should be N minus 2 times 180. Tells me how many degrees are in a quadrilateral. Well, that should be 2 times 180, which really means, from what we've done over here, that would mean from one angle, I should be able to form how many triangles? Yeah, 2. 2 triangles. So right there. Is there any other way to draw another triangle using a diagonal? From this diagonal? Or from this angle? No. I hit all angles. There's no other way to draw another, and I get all angles, and that's 2 triangles. So 2, so this is the number of triangles, times 180. That's how we get that formula. So those of you who can't remember the formula, say on your quiz or your test, well, you can reconstruct it. Just take your figure and separate it into triangles. Okay, to hopefully cement this for those of you struggling with it. Okay, I want to do one other thing. I want you to take and draw a pentagon. So use dots. Doesn't matter what the pentagon looks like. Draw your pentagon. Okay, so my pentagon is going to be right there. All right. Now what I'd like you to do from one angle, I want you to draw in all triangles and show that N minus 2 times 180 is the measure of the interior angles, and then calculate that, please. Okay, go for it. Okay, what is N in this figure? Yeah, 5, right? Okay. Everyone on your fingers, how many triangles were you able to make from one angle? Good, should be 3, yeah. Got 1 right there, 2, the middle one, and 3. So 1, 2, and 3 triangles. Okay, each triangle has 180 degrees, so we have N minus 2, which is 5 minus 2 in this case, times 180 degrees. Each one of those is 180. So that gives us 3 times 180, or 540. The sum of the interior angles of a triangle is 540 degrees. Any questions there? All right. Very good. Hey, last thing I want to talk about is called the exterior angle theorem. Okay? Exterior angles. Exterior angle says the sum of the measures of the exterior angles of any polygon okay, one at each vertex, is 360 degrees. All right, so polygon exterior angle. So just to kind of take that in, if I have my pentagon again, and on my pentagon, if I'm to extend my sides, so this says the sum of the measures of the exterior. An exterior would be, say, if I extend this line out, this angle right here is an exterior angle. Okay? If I'm to extend this line out, this side out, this angle right here is an exterior angle. Extending this out, so notice I'm kind of working around there. This angle right here is an exterior. Extending this one out, we have another exterior. And then once again, extending this one out, we get another exterior. So you get this like weapon of math here. You know, it looks like some kind of throwing pentagon thing. Pretty cool looking. Okay. So these angles, what this theorem says is all those angles add up to 360 if you add them all together. Okay. The question is why? Talk to your neighbor about it. Why is that? Okay, so after we go through these problems, I'll explain the why your exterior angles, or at least show something that will explain why they add up to 360. It would be a good visual demonstration. You can also show it algebraically, but we won't be doing that right now. Okay, number one, find the value of x in each polygon. All right. Well, first thing we need to do in order to find the value of x, any ideas? Cameron has an idea. Anyone else have an idea? Not that I don't like Cameron. Logan thinks he knows. Okay, Rory. Carson, maybe. You want to tell your neighbor what you think we should do first to try to find that value of x?
How did you make Oh. Yeah, there's a lot.
All right, Cameron, what do you think? Good. Everyone down there hear that? Way back there? What do you say? Okay, pay close attention. Okay, go ahead and say it really loud.
Find the total measure of angles.
Find the total measure of the, what type of angles? Interior. Interior is helpful. Okay. Interior angles. Find the total measure of the interior angles. So in this case, well, how many sides are there? 5. 1, 2, 3, 4, and 5. 5 sides. We can use our form. We could draw triangles if we want. We could break it into triangles, or we could use our formula. We know that n equals 5. So our formula is? Everyone on your paper, write down your formula. One you're going to have to use a lot this year. Okay, volunteer, what's our formula? James, what do you got?
N minus 2 in parentheses times 180.
Good, so we say the quantity, n minus 2 times 180. Okay, well, n is 5, so we'll dump that in right there. If 5 minus 2 times 180 is? Yeah, it's 3 times 180, or 540. Okay, that means all these have to add up to 540. Well, this is 90, and that's 90, and that's 90. So we get 90 times 3, or 90 plus 90 plus 90. That's 270. And we take that 270 and we can add another 127 to it. What are we at now? 397. So 397 is what we have. We need 540. So 540 minus 397 is going to be equal to our x. What's x? Good. 143? Yeah? All right, good job. 143. Got a second there. All right, so x equals 143 degrees. Done. Hey, it's really important you know how to use your formula, n minus 2 times 180. We practice there. Any questions on it? Okay, let's take a look at number 7. Find each measure, the interior angles of a regular hexagon. Interior angles of a regular hexagon. So an interior angle. So we just need one of a regular hexagon. What's regular mean again? Julian? They're good. Equilateral, equiangular. What's hexagon mean? How many sides, Priscilla, in a hexagon? 6. So if we have 6 sides and all angles are the same, well, tell your neighbor what's the first thing you're going to have to figure out here. Go for it. Figure out, Hannah? Good. So you're using your formula again. Well done. Yeah. So 6 minus 2 times 180. So that gives us 4 times 180. Or, what do we get there? 4 18s? 7 what? 20? Is that right? You have a second for it? I don't want you guys to just take someone's word for it. I'll second it for the sake of time. 720. If that's a regular hexagon, that means all angles are the same. If that's the sum of the interior, how are we going to find one angle? Anna? Yeah, divide it by n. In this case, to find one angle, once we get it, we divide it by 6. So we have to split it up equally. So one angle is?
120.
Yeah, 120 degrees. One of the coolest things I found, and you may even use this a lot, maybe even for number 7 after you see it for number 8. Number 8 says an exterior angle of a regular decagon. What do you know about all exterior angles? All exterior angles always add up to 360. So a decagon has how many sides? 10. If I know it's a regular decagon, that means all interior and all exterior are the same. Yeah. Yeah. You just take your 360 exterior and divide by 10. That gives you one exterior angle. One exterior angle is 36, which, by the way, if you know that, what's an interior angle? Think about a picture. An exterior angle and an interior angle, if that's them, if this is the exterior, this is your interior.
Oh, it's going to be 144.
Yeah, this would be 144. How do we know that? What type of angles are those?
Supplementary.
Supplementary. They have to add up to 180 all the time. So like in this one, this was a regular hexagon. We could have went 360 divided by 6 to get 60. And then we needed to have the supplement of that, which makes the interior 120. Dude, it's another route to go. It's kind of cool. It works in regular figures. Blow your mind, I know. All right, we're going to skip 10. Let's go on to number 11. Find the measures of each numbered angle. 2 regular octagons. Octagon has how many sides? 8. So I want this angle right here. It's an interior. And then I want this angle right here. Okay, work with your groupies there. Okay, ladies and gentlemen, what's an octagon interior angle? Go for it. 135. So we have 8 minus 2 times 180 divided by 8, right? N minus 2 times 180 divided by n, or in this case 6 times 180 divided by 8. All right? 6 times 180 is? 1080. Divided by 8 is that 135? Yeah, 135. Good job. So angle 1 is 135. Angle 2. Angle 2 is a combination of 2 exterior angles, right? What do you got? 90 degrees? Is he right? Yeah, we have 360 divided by 8. That gives you one exterior angle. In that case, that is 45? Yeah, so this one's 45, and this one's 45, so we get 90 degrees. Angle 2 is 90. Hey, guys, I am going to put on this for you, this video. I think it's a pretty good video demonstration of that, and it's up to you if you want to watch it, but we can show it algebraically as well. I personally would like it to work. That would be better. Let's try this again.
Okay, in this video I'm going to show you very quickly how to demonstrate that the exterior angles
I don't know if you guys can hear that
polygon
okay.
add up to 360
But
degrees.
you see the pictures for
so
sure.
to do that, I'm going to launch the Polygon Explorer, which can be found on the Visnos website. So do that.
You know,
Start off
Desmos.
with a triangle. Okay, so let's display the exterior clockwise. Move this slider now to make a nice big
You gotta
arc
check
here.
this out. It's pretty cool.
So you can see the exterior angles for a triangle are 120. Now let's find a general rule for all polygons in terms of the exterior. So what we do is if we reduce this radius, you'll see all the points come together and they form a circle. And everyone knows that in a
cool?
circle, the angles are all 360
That's pretty
degrees.
sick. Just
And
keep
you can see
watching
that
though.
there
They show
with
some pretty
120
cool
plus
pictures,
120
man.
plus 120, which is 360.
Show some good examples of it.
So that's pretty much it. Just to show you it works. For the
So they go to 4 sides.
4 for a square. Just change the orientation. Move it in. And you see the 4 parts of the circle.
They get turned in.
4 times 90 equals 360. Or if you want to find the other way
And just
around,
watch. Wait until they put
360 divided by
the
4 gives you 90.
large number of
Divided
sides up
into
there.
6 sides.
Yeah, your homework always gets
360
turned in. Yep.
divided by 6
You haven't
is
turned it in.
60
Turn it in.
Just open that up to show the polygon itself. So it's a hexagon there. So it's a quite nice and easy way to demonstrate it, really.
Check this one
one
out.
thing
It's
I
pretty
should
cool.
point out
And they get the
is,
concave ones.
in terms of radius, what does radius mean for a polygon? Because that's really associated with a circle. You can show the circle, which is by giving a colour. So there you have it there. And on any regular polygon,
We're showing
all
what a
the
radius
vertices
is.
lie on the circle. You might be asking, well, exterior angles for regular.
Oh, you guys are gonna miss. It's pretty sick.
Well, one way you can do this is move the points.
Watch it on the online video tonight. It's pretty cool.
The polygon
I think they
itself.
changed that up.
Drag points. Now, you can't use the radius here to reduce it
See ya.
because they're all going to be slightly different. They wouldn't come together at the same point, but they still do add up to 360 degrees. So maybe you could get your class to get the calculators out, add up all the angles, and see if that's true. In fact, you can even move on to a concave polygon if it's a more advanced group. And in this case, we'd be adding a negative number, which would compensate for these extra bigger exterior angles, and it would still add up to 360 degrees.
Isn't that cool?
Okay, I think that's everything. Hope you enjoyed watching this video. Come back for more. Thanks for watching.
Always make 360. That's awesome.